Hi everyone. So my name is Narendra. So I am doing my BTech third year in the stream of Electronics and Communication from Polarity Engineering College in Kurnool. So I have done my online internship on embedded systems provided by Emertxe Information Technologies. So in this project I have learnt about the introduction of embedded systems and its components and softwares which are used in this project and PIC microcontrollers, and specifically we have used the PIC 16F877 microcontroller. So we can implement this project by using the embedded C and the peripheral description, like we are using the LEDs, digital keypad and CLCD, etc. And finally I will show you the project demonstration and sample output. So let's going into the brief intro about this project. So this project explains about the washing machines. So we know washing machines which are used in daily purpose in our homes. So whenever we are washing a class human by using with our hands, so it will takes more time. So we are spend more time on that, but so for that purpose instead of human washing, so we are using implemented by using the automatic washing machines, so it can also save the human time. So washing machines are more important place in modern society, so customers want to have fully autonomic machines instead of semi automatic washing machine. So in this project I have built this simple washing machine prototype by using PIC 16F5 F877 microcontroller and coming into the embedded systems. So we know the embedded system is a combination of both hardware and software electronic gadgets to do a specific task. So some of the examples of embedded systems. So generally embedded systems we can see everywhere in our daily purpose, like microwave ovens and the ATM machines and the ACs. So there are so many examples of embedded systems. And coming into the washing machines and refrigerators and manufacturing plants in the industrial control and navigation systems in automobile medical device. In the every industry there is embedded systems which can implemented. So this is about the brief intro about embedded systems and coming into the types of embedded systems. So the embedded systems can be classified into the two types, that is based on the performance and functionalities required and the based on performance of microcontroller. So coming into the performance, there are four types of embedded systems are exist. First one is real-time embedded systems. So the name it indicates, so it can specifically perform the any task within a time period. So if it can pass this time period, the automatically the gadgets is destroyed. So here the time specific bond is particularly matter. So coming into the examples, we can take the rockets and the jets and missiles. So the real time applications which can be used in these type of applications. And coming into the second one, that is network embedded systems. So network embedded systems are used to communication between the one place to another place, one farm to another farm. So we are using the switches and routers and some hubs in for networking purpose. So here we can implement this type of embedded system for the communication. Coming into the third one, mobile. So we are using the advanced mobiles nowadays. So we can touch a mobile by using screen. So it can act as the sensors, touch sensor. Not only touch sensors, there are so many sensors and the different types of embedded components which can be inbuilt on the mobiles. So we can implement the more amount of projects by in the mobile industry also. And coming into the last one, standalone embedded systems. Standalone embedded systems, it can take the input and it can process it and we get the output. This is the basic operation of standalone. Like we can take the examples, washing machine, refrigerators, microwave ovens. So these are all come under the standalone. And the second classification is based on the performance of microcontroller. It can classified by three types: small scale and medium scale, sophisticated. So this is the about the types of embedded systems. And coming into the next one, the major components which can be used in the embedded systems. So I have already said the embedded systems are microcontroller or anything. It will take the input and it can process it and will get the output. So in the input side, we will use the different types of sensors like Digital keypads are also using for the input and all sensor, temperature sensor, humidity sensor, light sensor, IR sensor, different types of sensors for the input, and it can be converted into the analog to digital form by using the different types of force which can be implemented on board. Coming into the process, after converting into the analog data into digital data, it can perform the some operations by using the CPU. CPU is nothing but we can assume it as a microprocessor and microcontroller. The main operation which will be implemented on this CPU part. So after completion of a very process or any task, so it can be converted into the analog form. It can be in physical form. So here the actuators which can be act as the transducers. Not only actuators, sensors are also act as the transducers, so which can be converted into the energy one form to another form. Here the actuators we can see the output in physical form like LCD, and we will take the LEDs and the buzzers. There are so many actuators which can be see the output. And coming into the memory, two types of memories as exist, RAM and the ROM. So random access memory for the general purpose operations used, and the ROM, that is, this is a permanent memory. We can store the data in this memory. And FPGA is a field programmable gate array. There are different types of IC chips are used to this FPGA, and this is the basic block diagram of embedded systems. And coming into the next one, PIC microcontroller. So particularly in this project we are using PIC16F877 microcontroller. So it can be provided by the microchip company. So it is one of the majorly used microcontroller in the industry. So particularly automotive industry is mostly used this microcontroller. And coming into the pin description, so it has the 40 pins, and it consists of 5 ports in total: port A, port B, port C, port D, and port E. So in the port A it consists of a 6 pin, and port B 8 pins, port C 8 pins, port D 8 pins, port E 3 pins, and also extra we are using the power supply and the ground and extra pins for its running. And also it can support the serial communication for it has a 2-pin transmitter and receiver pin. It can also support the SBI protocol, serial peripheral interface, and it is clock frequency range between 4 megahertz to 40 megahertz. So this is all about the PIC microcontroller. And coming into the softwares which are used in this project, those are PIC SimLab and MPX Lab IDE and XC9 compiler, PIC Genius. In this PIC Genius we have to select particular board by in the PIC simulation lab. So here we can see that PIC16F877A microcontroller board. We are using this board in this project. And PIC simulation lab. In the PIC simulation lab, it is a virtual software. We can implement our project in virtual way. Here there are so many types of microcontroller board are provided by these software. Like we can take the Arduino and MSP430. So there are so many boards are provided by these software, and the MPX Lab IDE. So we use this software for the writing the program and compilation for the PIC16F877A microcontroller. So these are all about the softwares which are used in this project. And coming into the embedded C. So why we are going into the C? Why? Because of if we are taking into the Java, Python and anything, so its process is very less as compared to the C language. And C language is portability, and also it is relative closely to the architecture of microcontroller. That's why still C language is implemented in microcontroller projects. So C is the important for embedded systems. Why? Because of its efficiency and portability and low level access. There are so many advantages in C language for implementing the embedded system project. And coming into the main contents in C are data types and variables. So we know the data types. There are different types of data types. Data types are nothing but which type of data we are using. So I take an example, that is 10. So 10 is a integer value, so we can give the integer 10. For the variable, every value we have to indicate by a variable is nothing but a named memory location. So integer a is equal to 10. So whenever we have to show the output on any compiler, any console, we have to only declare the a, then we will get the output. And coming into the pointers and memory management, so pointers manipulating the memory address and access the hardware registers directly. So by using these pointers, we have to use the address of the pointer, we can declare it anywhere, and control structures, implementing the decision making logic and the repetitive task. So control structures coming into these type of topics, we are if else and else if ladder. So these are all the control section, and also loops are also existing in C language, that is for loop, do loop, while loop. These are all used to execute the program multiple times. So we can also implement in infinite times. Most of the times these loops we use in embedded C. Why? Because of our projects can be run so more than 10 years, more than 1 year. So that's why we are using loops more. That's then coming into the functions and the modular programming. So functions are used to reusable the code blocks and facilitating the modular software design. And coming into the last topic, that is pre-processed directives, manipulating the sound source and before compilation for defining constant and conditional compilation. So this is all about the embedded C. I have learned from this internship. And coming into the next topic, that is peripherals. So we can take the peripherals like LEDs, LCDs and digital switches and buzzers and the DC motors, anything. These are all the peripherals which can be implemented in embedded systems project. And coming into the LED, it is a light emitting diode. It is a semiconductor device which can emit a light whenever electric current passes through it. So here we can see that the LED, it consists of two pins, that is positive anode pin and negative cathode pin. So here the positive pin which can be connected to the port pins of a microcontroller, and the negative pin can be connected to the ground. So LED is an external device which can be connected to the microcontroller port. LEDs are we can use commonly for indicating the lights, displays, illuminations. So this is all about the LEDs. And next one is tactile switch as digital keypad. So we have to use this for the whenever we are pressing this button, so the it can be in the on state. So whenever we release this switch, it is in the off state. So like we will take the example LED by using the switch. Whenever I will press a switch, the LED is on, otherwise I will release the switch, the LED is off. So it's only because of performance of the switch. So whenever I will press this button, the current passes through it, then the LED is on, otherwise it will be off. So this is about the digital keypad. And coming into the next one, that is CLCD, character liquid crystal display. So it can be used to display the images or the characters and some extra characters in the LCD display. So it can be operated by the liquid crystals controlled by the electric signal. The main pins in this LCD are VDD and VSS for power supply and the ground. For the control purpose, we are using the RS, RW and enable. And the data lines are D0 to D7 along with the V output pin, analog and cathode and anode. Here we can see this LCD. Here the pins in the CLCD all arranged in this order. So this is all about the CLCD. And the next one is interrupts. So interrupts in microcontroller, there are two types of interrupts. It can be a hardware interrupts or software interrupts. Interrupt is nothing but a temporarily suspend the normal program which can be executed the another specific program whatever we given as input. So for example, I will take the sensor, IR sensor. So whenever the person or light is fall on the sensor, automatically the LED is on. So it can be act as a interrupt. So it can stop the microcontroller program from that state. So this is about the interrupt, and the internal or external requires the microprocessor unit to stop the processing. There are two types of interrupts, that is hardware and software. And coming into the next one, timers. So timers are used to maintain the time delay in microcontroller, and it can also generate the time signals bit by bit, and it can implementing the time critical operations. They can be configured to operate in various modes by using the counters and PWM pulse width modulation and capture and compare modes. Different types of requirements which can be using these timers. Timers are offers the future adjustable prescaler and reload values, allowing for fine grained and control over the timing resolution and period, essential for applications such as motor control, communication protocol, and real-time system. So this is about the timers. So now I will show the project about whatever I have implemented in this project, that is a washing machine control. So this is the 16F877A microcontroller. This is the Peak Genius board. We have to select it in this board, Peak Genius. So I have already selected, and then we upload the code. Upload the code. I have selected this one. Our code is uploaded to this board. We have to press this button for reset. So I have already uploaded the code. So here we can see that in CLCD, press key 5 to power on the washing machine. So whenever I will press this switch 5, so it can shows the washing programs daily heavy and whites and heavy whites and delicates and eco cottons, and different types of options we are available for washing. So I will select the woolens. So after pressing long time this switch, so it will go to the which mode of operation we have to wash our clothes. So I will press this long time. So we have to wait for a few seconds because of it will take time. So here we can see that the different types of modes we have to implement it in water level, that is auto and the low and medium, and the next one low and medium and high, medium, high and maximum, high and maximum and auto. So I will again long press this auto. I will select this auto mode. I have to again press this button long time. So here we can see that when I switch 5 for the start the washing cloths, and so I will press this switch 5. So here we can see that the our clothes are washing. So we have to stop our clothes washing. So I will press this switch. So here we can see that whenever I will press the switch button 6, the fan is off. So like the clothes are off washing. So I will press this button. We can see that the how it will operate. So the fan is half, so it is in the half position. So again I want to wash my clothes. I have to press the switch 5 button. So I will press now. We can see that I will press this. So my clothes are washing now. Here we can see that my fan is running. So we have to wait for the few seconds. I will set the timing 30 seconds. So whenever this timing is completed, automatically my washing machine is stops. It will show the buzzer to me, indicates the my washing clothes are completed. So we have already seen that programs are the clothes are completed. It will shows the buzzer to me. So not only this project, we can also implement that so many projects by using these Peak microcontroller board and the MPX lab IDE. So that's all about this project. So thanks for Emertxe for providing this type of internship for me. So thank you.